Hello everyone. I'm Sudha, working as an Associate Professor of Chemistry in Nalana Simha Reddy Engineering College. In the previous lecture, we have seen about the molecular orbital energy level diagram for nitrogen. So now let us see the molecular orbital energy level diagrams for oxygen as well as fluorine. So first let us see for oxygen molecule. Oxygen has the atomic number of 8, which has the configuration of 1s2, 2s2, 2p4. So this is the atom containing paired electrons in the p orbital. So as I explained in the previous lecture, the atoms with the paired electrons in the p orbital shows the normal pattern of the energy in the molecular orbitals. That means after sigma star 2s, the next higher energy orbital is sigma 2pz, then pi 2pz. This is different from nitrogen. So for the atoms with paired electrons in the p orbital, the energy order is sigma 1s, sigma star 1s, sigma 2s, sigma star 2s, sigma 2pz, pi 2px equals to pi 2py, pi star 2px equals to pi star 2py, and sigma star 2pz. Now this oxygen molecule has paired electrons in the p orbital. That means 2p4 is written as 2px2, 2py1 and 2pz1. So as two oxygen atoms combine with each other and form an oxygen molecule, 16 electrons are to be filled in the molecular orbitals of oxygen. Now the electronic configuration for oxygen molecule is represented as sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, sigma 2pz2, then the electrons enter into pi 2px, pi 2py. So the filling of these orbitals takes place as per Hund's rule. So pi 2px2, pi 2py2. Now till here 14 electrons are filled. Now the remaining 2 electrons are distributed equally among pi star 2px and pi star 2py, because these are again degenerate orbitals. So once these orbitals are half filled, then pairing takes place. So as 2 electrons are left over, those 2 electrons are singly filled in pi star 2px and pi star 2py orbitals. Okay, but not the 2 electrons are filled in pi star 2px molecular orbital. So this is the electronic configuration for oxygen. Okay, and this is the molecular orbital energy level diagram for oxygen molecule. The two atoms and their atomic orbitals are shown on the sides, whereas molecular orbitals are represented in the middle. So sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, sigma 2pz2, pi 2px2 equals to pi 2py2, then pi star 2px1 equals to pi star 2py1. So till here 16 electrons are distributed. Now let us calculate the bond order. That means how many bonds exist between two oxygen atoms in a molecule and what is its magnetism or magnetic properties. So the bond order is calculated as I explained you in the previous lecture, half into number of electrons in the bonding molecular orbitals minus number of electrons in anti-bonding molecular orbitals. So there are 10 electrons in bonding molecular orbitals and 6 electrons in anti-bonding molecular orbitals. See here, 10 electrons, 2, 4, 6, 8 and 10 electrons in bonding molecular orbitals. Anti-bonding molecular orbitals have 2 plus 2, 4, 5 and 6. So 6 electrons are there in anti-bonding molecular orbitals. So half into 10 minus 6, that equals to 2. So a double bond exists between two oxygen atoms in the oxygen molecule. Now coming to the magnetic properties, as the pi star 2px and pi star 2py molecular orbitals are singly filled, that means they have only one electron. They are not paired. So 2 unpaired electrons are present in the molecular orbital configuration of oxygen. So as it contains unpaired electrons, the oxygen molecule is paramagnetic in nature. Now this is one of the property that was explained by the molecular orbital theory, which was not clearly explained by valence bond theory. This is one of the drawback of valence bond theory, which was clearly explained by molecular orbital theory. So oxygen molecule is paramagnetic in nature because of the presence of unpaired electrons in pi star 2px and pi star 2py molecular orbitals. So that is about the molecular orbital energy level diagram for oxygen molecule. Now next is molecular orbital energy level diagram of fluorine. So fluorine also has more than 3 electrons in p orbital. So fluorine has the atomic number of 9. Its configuration is written as 1s2, 2s2, 2p5. That means 2px2, 2py2 and 2pz1. So it also has more than 3 electrons. So the energy order of the molecular orbitals is the normal pattern. That means sp mixing is not prominent or it is almost negligible in fluorine molecule. Now, as there are 9 electrons in each fluorine atom, and as 2 fluorine atoms overlap and produce a fluorine molecule, 18 electrons are to be filled in the molecular orbitals of fluorine. Now, if we see the electronic configuration for fluorine, it is written as sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, sigma 2pz2, pi 2px2, pi 2py2, pi star 2px2 and pi star 2py2. Okay, so all the 18 electrons are filled in 9 molecular orbitals. This is the molecular orbital energy level diagram for fluorine. And coming to the bond order and magnetic properties, the bond order is calculated as half into Nb minus Na. So there are 10 electrons in bonding molecular orbitals and 8 electrons in anti-bonding molecular orbitals. So half into 10 minus 8, that equals to 1. That means a single bond exists between 2 fluorine atoms in a molecule, which is a sigma bond. And as there are no unpaired electrons in the fluorine molecule as per the diagram, after the distribution of the electrons in the molecular orbitals, there are no molecular orbital is singly filled with 1 electron. See, all the orbitals are completely paired with 2 electrons. So as there are no unpaired electrons, fluorine molecule is diamagnetic in nature. Okay, this is about the magnetic properties, bond order, molecular orbital energy level diagrams for oxygen as well as fluorine. So that is about the molecular orbital energy level diagrams. Thank you.